Hi, I'm Lindsey Kwok. I'm a graduate student at Rutgers University, and I study exploding stars called supernovae. So we use JWST to observe the normal and type 1a supernova called 2021aefx. Now, a type 1a supernova is a white dwarf that explodes. A white dwarf star comes from a star about like our sun that runs out of fuel, but it's not massive enough to actually collapse into a black hole when it dies. And the white dwarf basically is the sun, but squished into the size of the Earth. So it's really compact, and if it gets more mass from a companion star or like colliding into another white dwarf, then it can explode again. So we used JWST NIRSpec, which is a near-infrared spectrograph, and MIRI, which is the mid-infrared instrument. And so we took a spectrum, which is basically like you put light through a prism and it makes the rainbow. So we spread out this light into its wavelengths, and we got the first continuous spectrum all the way through the optical, near-infrared, and mid-infrared of a supernova. And what we can see from the spectrum is like what kind of elements are present in the ejected material. So we see nickel and iron and cobalt, and then in the mid-infrared, which we really need JWST for, we see argon. And that's a pretty cool new element. Some of the things we learned from what we see in the spectrum is that the white dwarf would have been a very big white dwarf, close to that upper mass limit. And we also see that the argon extends to higher velocities, which means that it's like located physically further out, whereas the metals are located closer to the center. And that tells us that the explosion was a detonation, which is a really fast or supersonic explosion. We are really excited about JWST and future observations of type 1a supernovae with JWST, because we really don't have very many spectra at all. There were only 4 total supernova spectra in the mid-infrared before this, and there was only 1 of each. Now we are going to have 4 of just Supernova 2021aefx. And then our program is going to be observing 8 more supernovae as well. So getting more data is just going to really open up our ability to understand the physics behind these explosions. And then we're also really excited that in our program, we're going to be observing some of these weird and peculiar white dwarf supernovae, and we've never gotten a near-infrared and mid-infrared spectrum of those before. So that will be completely novel, and it's going to help us unravel what physics makes these objects so peculiar. I'm really excited to see where this is going to go. There's so many exciting new avenues. There's dust stuff. There's a type like core collapse supernovae. The possibilities are really opening up.